All right, so how to solve a system of equations using substitution. So there's three ways to solve a system of equation. Way number one was graphing. Okay, and that one's pretty simple. It's kind of one of the least, I guess, useful methods, just because you can only use it when the equations are in y equals mx plus b, or in a nice, neat cover-up method or standard form, if you will. So here, okay, we have x equals -9, and then we have -6x minus 8y equals -2. Okay, so substitution works best when one of your variables is by itself or can be easily gotten by itself. So notice x is by itself here. So I'm going to take what x equals to, and I like to draw an arrow to where I'm substituting it in at. So I circled the -9, I'm going to draw that to the x because that's what I'm replacing. So I'm going to go ahead and replace that. So I have -6 times -9 minus 8y equals -2. And I'm going to go ahead and I'm going to simplify this out. So 54 minus 8y equals -2. And then I'm going to subtract 54 from both sides. Okay. And let's see, -8y equals -56. Okay. And then I'm going to divide both sides by -8. Sorry, I'm running out of board here. Okay. So I'm going to get y equals 7. And now I have my answer, which is -9 and 7. All right. So this is for Algebra 1, U8. Okay. And I'll let you guys look at that for a second. Okay, so I'm going to type in -9 and 7. All right, and the next problem I got the next problem is 4x plus 3y equals 19. 4x plus 3y equals -19. And then it says y is 3. So notice here y is by itself. All right, y is by itself. So I'm going to take what y equals, which is 3, and I'm going to draw my arrow up to that. And I'm going to replace that y with 3. So I have 4x plus 3 times 3 equals -19. And I'm going to go ahead and simplify here. So I have 4x plus 9 equals -19. Subtract my 9. And I'm going to have 4x equals -28. Divide by 4, and you get x equals -7. So my answer is -7,3. And as you can tell, there's a lot of work that goes into this, and there is a lot of space needed. So when you're doing these problems, make sure you plan out accordingly. Okay, so -7 and 3. All right, so not every problem is going to be nice and simple like that. Okay, they'll start to change. So most people for this problem would like to graph, but I beg you to reconsider. Okay, we have y equals 2x minus 6. And then we have y equals x minus 1. So the reason why I ask you to reconsider is in order to graph this, you guys have to go ahead, draw your coordinate plane, and you need a ruler and all this stuff. But if you just know how to substitute, okay, notice the y is by itself. So I'm going to go ahead and circle what y equals, and I'm going to plug that in. So I'm going to have x minus 1 equals 2x minus 6. And now I'm going to go ahead and I'm going to get all the x's to one side. So I have -1 equals x minus 6. I'm going to add 6 to both sides. I'm going to get x equals 5. So now what I do from here is I'm going to take that value of x, I'm going to plug it back into this equation. It doesn't matter for this one, either the top or bottom. So I'm going to take 5 and I'm going to plug it in for x. So I have y equals 5 minus 1. Well, y equals 4. So my answer is 5, 4. So 5, 4 is my answer. Okay, so you're going to have a couple of those problems. The goal is to get one of the variables by itself. You might have to, like, you know, move the x's or move the y's to the other side. But the goal is to look at the equations and see that it's easier to get one of the variables by itself. I'm going to see if I can get you guys one of them so you can see what it looks like. But you want to get a variable by itself and then solve for the other one. All right, so let's see. I'm just seeing if I'm going to be able to get a problem by itself, and it doesn't look like it. So if you guys have any questions, just let me know, and I'm more than happy to work out more for you. Okay, good luck.